What is up guys, CryptoMax, also known as Zoid right here, and in this video I'm going to be showing you how to create a JavaScript Recon tool with Go language. In this particular program, what it's going to be doing is using a couple of regular expressions to grep through a whole heap of JavaScript files and looking for patterns. This is going to be specifically programmed in Go language, and without further ado, let's get started, eh? So I'm going to call this program linkJS. Just a simple program. I prefer to call it linkJS because it just seems right. Okay, let's start off with a package. Package of main. All Go language programs starts off with a package. That main can be called whatever you want. It's just a package that we can include in other classes, other programs. And we're going to import a few modules. We're going to import FMT for printing to the console. We're going to install time and sync just for the Go routines. We're going to install import regexp. Sorry, I didn't mean install, I meant import. We're going to import these modules. And what other ones can we import? Time. We've got time. We need OS and buff.io. We need. I'll go through each one, what they all mean. I'll just import these at the moment. Okay, this is about all we need. So let's go one by one. FMT is for printing out to the console. Time is for sleeping and waiting, sort of like halting the instruction. So we might put time.sleep1 and it might just sleep 1 second. Sync is for our Go routines. Regular expressions are going to be used for our pattern matching. OS is for our operating system, where we're going to use standard input for other tool chaining techniques. Buff.io is to read a new scanner. This is for network communication through HTTP, and this is input-output, which is going to be used for reading in the response body. Let's start off with creating our function main. And this is pretty much where the function always starts in a main function. Let's first start. Oh, we also need flags, by the way. Let's get flags in. And let's start with defining our flag. So we need a variable called concurrency. And this is going to be of type int, and this is going to be used for our speed of the application. Now, we've got var. We've got the variable name concurrency and the data type int. So that's pretty much in the format of var, and then it's variable name, var name, and then data type. That's pretty much how you define a variable in Go language, but without, that's pretty much how you do it. We're going to be using this regular expression later for our pattern matching. We're going to grab a few others too, but we're just going to be using actually, no, we'll just stick with the link finder in JavaScript, just for simplicity, and you can add to it later with adding other regular expressions and things like that. So let's put our flag. It's going to be int var, and we're going to put in our pointer, which is concurrency. The default concurrency will be 30. So the first argument is the pointer to this variable. The second argument is the parameter name. So we'll call it we'll just call it C. The third argument is the default value of, we just put 30, and the fourth argument is what the flag means, what the variable is meaning. So this is like what the helper, basically, what the variable means. So we'll put set concurrency for greater speeds, Okay, and then the next one would be to pass the flags. So we can use the flags, because if we don't put flag.pass, the flags won't be used, and we won't function properly. Next thing is to create our Go routine. And how we do this is with a wait group. So we're going to create a variable called wg, which means wait group, and we're going to put this syntax here. So it's sync.waitGroup. And then we're going to create a for loop defined like so, with for I equals. How you do an equals in Go language is with the double column and equal. That's how you assign a variable, and it's going to be initially assigned to 0, and it's going to iterate from 0 to the concurrency that we set. So concurrency, and it's going to increment by 1. Alrighty, so now we need to add the wait group just by going wg add 1. And then we just find our coroutine. So we go func, and this is pretty much how you define a go routine. Pretty simple, hey? Now we need to, in this go function, we need to specify a function that we're going to call multiple times with greater speed and concurrency. So we'll go grep. We'll make this we could call this get links. Might be a good name for it. We don't need to pass any arguments for now. Any parameters into the function. But we also need to wg.done, because once this go routine is done, we need to call done, and then we need to wait for the next go routine. That's pretty much how you do it. Another thing, we could probably put a a regular expression flag. Then we can set our own regular expressions to whatever you want, but we'll just keep it predefined in here for now. And what I'm going to do is I'm going to create a global variable called linkRegX, just to see this, just so we can actually get this working first. Let's put that linkRegX there, and put it like that. Just so we can actually have a global variable. This might come up with an error, but we'll find later. We'll just see what we can do now. So let's create a function get links. Actually, what we could do is we could, instead of doing global variable, we could just pass it into the function. So we'll put var link regex. This will be assigned to this one here, and then we just put get links with regex string type. Perfect. That's how we do it. And this will be link regex. There we go. Perfect. Now we need to start doing the core of the program. Let's just save this. Let's just go down, create a few spaces so we can see what we're doing, and let's zoom into this get links function. So first of all, we want to sleep only for a small amount of time. Otherwise, the program will not work. The go routines will not work. So we're going to just sleep for 10 milliseconds. And then we're going to create our client, which is going to be for making requests. And this is how we do it, pretty much as follows. Okay, cool. Now, next thing is to create our scanner object, which will be used for standard input, writing to standard input, reading from standard input, which will be used for tool chaining, which is used like that. That's how you define it. Then we want to scan. Now this is pretty much how you scan through standard input, which is through creating this new scanner with standard input. So scanner equals buffer new scanner OS standard input. That's how you define a scanner object, and then you just go for scanner.scan. So what happens is once it's reading the standard input, while it's reading the standard input, it will be true, this function, because scanner.scan is a boolean, returns a boolean. So this will be true if there's something to read, but if there's not, it'll be false, and it will just like pretty much end the for loop and be complete. Let's put our JS link here, and this will be defined as our scanner.text. Pretty much that's how it's going to work. Then we need to define our request. We need to make a request to the JS link. It returns two values, which is a request and an error. We need to use HTTP make, new request. And the first argument is the method type. We'll just use get. The second argument is the thing we're fetching, or things we're based the URL. And our last argument is just the body. We're just going nil. We need to check to see if there's any errors. So if there's an error, is equal to nil, and if this is true, there's an error. So we'll just return like so. Next thing is to make the request. So we'll return a response, also an error, and we need to go client do, and we'll make a request. Get a response back. If there is an error, we will just return again, just doing the basic error checking. We'll return Alright, cool. Now we need to get the body buffer. This is by using IO util, and we need a read or response.body. So this is reading all the response body. So make a request, we get a response back, all the body. So basically everything that contains JavaScript code will be read, and put in a variable, which is a string variable, which will go body string, because we need to convert the buffer to a string. So it'll be body string, and then string, cast the body buffer to a string. So that's how we do it. And that's awesome. Pretty much that's it. Now this is where we need to do the regex magic. So in order to do this, we need to create a RE variable, which is going to be set to regexp. We're going to, I think it is, let's have a look at the documentation real quick. I think you will find it under regex Go language. And right here we have the documentation for regular expressions, and what we want to specifically use is find or submatch. Find string submatch. That's what we want to use. Pretty simple. That's how we do it. So it's must compile. So must compile is what we need to use initially, and then we need to put in the link regex. I think I defined it as, what was the variable argument name, which was this regex. Okay, cool. So we're putting in regex. This is going to compile the regular expression, so it's used. Then we need to just simply print out the regular expression. So we're going to go match equals ra.find string submatch, I think it was. And this will be what we're going to try and match. So this is the object. This is like, we're going to use a regular expression, and we're going to match. I'm going to use that regex to match all the links into the body string. And then we're just going to simply just print out as a format, and we're going to go %q / new line, and then print out the match. And the very first object in the array, which would be just the link. Pretty much that's how we do it. Let's save this. Let's build it. There is an error on line 117. So sorry, line 17. There's an error. So let's go to that line, which is this. This one here is has the error. So let's just get rid of the var and now compile it. Now it's saying read all returns two values. So I just actually remembered read all returns an error as well. So let's do this. So let's check to see if there's any errors. And let's just do that quick error check, and we'll return nil if there's an error. Return actually if there's an error. And also this is going to be on GitHub if you want to use this. Let's go and build it. Perfect, thumbs up for us. We actually got it successfully compiled. Let's have a look at the program so you can have a rough understanding, so you know what it looks like. This is pretty much the program right here. If you need to pause the video and follow line by line on how to do this, pretty much it. Or I can just post the code on GitHub and you'll be able to use it there. But that's pretty much the code there. Now let's use this with some tool chaining. So we're going to first use subfinder, and we're going to use the domain, just a very small domain. Do you know what we'll do? We'll use we'll just start off doing a single domain, but we can use subfinder, and we're going to use Yahoo, www.yahoo.com. Now we need to change. We actually need to use a program called get.js to be able to get all the JavaScript files from a domain. And we're going to use the complete flag, because if we don't use the complete flag, it's going to completely ignore this section here, the https ://www. It's just going to print out the endpoints, which we don't want. We want actually a whole domain. Well, like it says, complete will complete our example appending the domain to the path, which is what we need. And then we just basically use linkJS, and it should actually theoretically fetch all the JavaScript names. Obviously, it did not like the index because it was an index problem. There was an out array index. So let's just match it and let's see what we can do about this. So if I build again, and what the error is it actually has some things that start with nothing. It doesn't find nothing, and then it finds some things. So what we need to do here is we need to do a basic error check. we need to check to see if anything in the array is, if the array is contains nil, then we just return. So if match is not, so if it's not equal to nil, meaning there is something that's found, it hasn't it has found something, then we'll print out the results. If not, we just do nothing. So it only prints out what it's found, and we also need to specify the first array index, because that's what contains the file, the link. Let's have a look now. Okay, it's still coming with error because I forgot to compile. Now let's run it. There you go. Now it should just print out the JavaScript, all the links that it's found, and it will go pretty quick, and then it should just return. Should just quickly return. It's very fast. We can do a sub finder. We can increase the concurrency for greater speed, and it will find all the links in JS. So let's have a look at this command here. Let's have a look at this. Let's just zoom in and see what it's going to do. And what we can do is we can use concurrency for greater speeds, which we'll have test out in a minute once this has loaded. Let's see what happens. Alrighty, here it is. Here's the final test. Let's see if it works. So what we're doing here is we're using subfinder to fetch all the subdomains from paytm.com, but silently it's not printing out any output, just the subdomains it's found. We're getting all the JavaScript from those domains, and I just realized we need to actually resolve these domains. So let's resolve them before it works. So let's go resolve HTTPX, and it should resolve them, and then it should print out the JavaScript files. But I actually just want HTTPX to be silent, so let's have a look at the flag there. So we want silent mode. Okay, let's do that. Silent. And this should fetch all the JavaScript files. Pretty much it. But what I might do just to make this run a little bit faster is just ignore. Let's just tee out a couple of domains. Let's go hosts. Let's just tee out a couple, might be easy. Let's just tee out that many. And then we can just go, we can go cat hosts. And that should be a little bit faster. There you go, it's finding all the links. It's going a little bit slow, but it hasn't found much at all. But if we speed this up to 100, it will go really fast. Watch this. There you go, just already done. Look at that, it goes much faster. If you compare it, it goes a lot faster. There you go. Now, if we do a subdomain scan, we'll find a lot more. Let's actually make this into a recon tool. So what we can do is we can copy this. We can go get a bash script out. We can go find links.sh, and we can include our bin bash interpreter. And for the first argument will be the domain name. We check to see if that domain is actually set. If it's not, then we'll just print out something like usage. Please enter a domain name. And then what we do is we're just pasting this command, which is the subfinder. We put in our domain we're testing, and then we resolve them. We teed out the host, and then we go cat hosts, and then we go get link.js, and then pretty much that should be it. Let's make sure this is right. Perfect. Let's mod this, find links, and this is pretty much how we do it. Find links. What we need to do first is we need to just exit if it can't do that. Okay, that should be it, I reckon. Let's first of all, it's saying enter domain name. Let's do what's a small domain we can enter? Let's just do paytm.com, and that should find all the domains, and then a JavaScript. But the thing is, we don't want to actually print out the results, so we just need to find out a way that we can use subfinder to actually not print out the output. What can we do for this? We need to silent, which is only show subdomains, but we don't want it to display nothing, which is the next step to do. Verbose will show verbose output. We just want it. We don't want it to print nothing at all. So that's the thing we need to look at. Use all sources for slow enumeration. That's what we need to put as well. That'd be cool. So all would use all sources. But what we can do is we can pretty much just append this to a file called hosts, and then we can cat out hosts, and then pipe it to HTTPX, and then append this to resolved, and then cat out. Whoops, my bad. I'll do that again. So we can pretty much append. Let's just do this again. We can append it to hosts, then cat out hosts, and resolve them with HTTPX silent, and then we can append that to resolved, and then cut out resolved and find all JS links. Now that will make sure that it actually does not output anything, so only the JavaScript files. There you go, that should work fine. And let's just I really wish we could do a small domain. Just it might be a lot easier, but let's just put here a little text saying something like, please be patient for links to please be patient finding links. But also what we can do is we can just make it so we can use this bash script to find subdomains, or we can just print out a single domain, which is just echo. Which, if you know it works, this is the find links function here. We've got a go linkJS function program, sorry, and if we just use cat resolved get.js, it should work fine. Sorry, linkJS, it should work fine. Pretty much need to get the JS though first. So get JS and then do that and complete. So that will work. We just need to implement this in a link finder, and it should be all complete. And you'll have your own very own JavaScript Recon tool where you can find links inside JavaScript files. Now I'm going to be explaining why this is so useful. As I just type in this bit of code here, so just wait. There you go, cool. Now, why is this so useful? Now, okay, I've had experiences where you find an SSRF vulnerability, and you can never find out internal domains to actually hit. And this is where you need to actually read JavaScript to find out internal domains or internal resources that we can hit with our SSRF, because SSRF by default is not a vulnerability. It could be made by design. A lot of people report blind SSRF as just, you can hit your own server, you got blind SSRF. A lot of times, you'll be lucky to get paid, but a lot of times it'll be not applicable or informative, or they just won't approve it. Might just say made by design. I don't know why people can report it and get paid. They're just lucky, because a lot of the times you need to prove your impact with SSRF by hitting internal resources or internal services like OR's metadata instance, REST APIs, admin panels, things like that. You need to be able to hit before you can report it and get a critical vulnerability and get paid lots. Anyway, and you might find API keys, leakages, DOM access, things like that. So another thing is you can turn this into, you can have more, you can pretty much make it so it actually greps a regular expression. So you have you might say match, and you might put your match, your regular expression here. You could make it so it does that, but I just wanted to finds links. So I hope you enjoyed this video. Please like, comment, and subscribe. Give me a big thumbs up. Tell me what you think. And have a great day, you hackers. Use the legends.